So far in these skill assignments, you've been working to do the really important task of psychological science of locating empirical journal articles, reading those articles, and being able to begin interpreting those articles. But so far, you've probably struggled with one particular section, that is, the results section. You've sort of had to take researchers at their word. You've been learning the language of psychological science, and I see you taking strides in understanding the introduction and the methods section, and in understanding how the theory works together, the points that the author is trying to make, the references to other research that the author is working on in the introduction, and also the basic design, recognizing when something is correlational or experimental, recognizing those independent and dependent variables, really critical pieces to understanding psychological science. But when it comes to the results, there's a lot of language that you may not understand, or that you might know parts of, but not quite know how to interpret. So what I want to do in the following skills is focus on how to interpret some common statistical tests that psychological scientists rely on when they're trying to look at the associations between things or the differences between things. So the first set of analyses that I'd like to talk about are correlational analyses. So as you've already read in your methods section and in understanding through other areas of the course, there are two types of studies that we tend to talk about in psychological science, either correlational studies or experimental studies. And what we mean by a correlational study is a study that is attempting to look at whether two or more variables tend to co-vary. That is, do they appear together, or do they never appear together, or is there no relationship between those variables? What makes something a correlational study, and this is a really important point, is that the variables that you are looking at are all measured. That is, they exist out there in the world, and you go out and measure those variables. So you might measure someone's gender, or you might measure someone's personality characteristics with the Big Five, or you might measure their humility, or you might measure their helping behavior. Any number of things that exist out in the world that you want to measure. What we do with correlational studies is compare the measurement of some construct with the measurement of some other construct, and we see how frequently they appear together. When we talk about correlations, we usually represent those correlations with a Pearson's R correlation coefficient. That is, R equals some number. And I want to talk just a little bit about what that value means. R is an estimate of the covariance, how much X and Y appear together. In this unit, we're going to talk about those correlation coefficients and what they are, but in Psych 241, when you get into statistics, and in 245, when you get into research methods, we're going to talk about how to compute them and some more details about how to interpret them. But right now, I just want you to have a basic literacy of what correlation coefficients mean. The value of R, the value of the correlation coefficient, can range between 0 and 1. Any values outside of that, above 1, are not correlation coefficients, or not appropriate correlation coefficients. A value of 0, R equals 0, means that there is no relationship between the variables, that knowing something about X doesn't tell you anything about Y. Let me just give you an example of that. If I had, for example, the relationship between height and IQ, we might want to figure out, what does knowing someone's IQ tell me about their height? As IQ goes up, what happens to height? Well, assuming we're looking at adults, there is no relationship between intelligence and height. So as a result, the correlation coefficient between those two things would be 0, because knowing something about someone's height doesn't tell me anything about their intelligence, and knowing something about their intelligence doesn't tell me anything about their height. They are not correlated. There's no relationship. However, most things are correlated in some way. Knowing something about X often tells us something about Y. So we also have relationships where R equals 1. So we've talked about where R equals 0, where there's no relationship. When R equals 1, the two variables that you're looking at are actually the same thing. That is, as X goes up by 1, Y also goes up by 1. So what if I were measuring height in both inches and centimeters? Well, as height in inches goes up, obviously height in centimeters goes up an exactly equivalent amount. So we get a correlation of 1, where knowing something about X tells me everything I need to know about Y. X and Y are precisely the same and equally related. Most things, however, are not either completely unrelated or perfectly related. Instead, the vast majority of correlation coefficients fall somewhere between 0 and 1. Let's say, for example, that I wanted to understand the relationship between height and weight. So unlike the relationship between height and intelligence, where there's no relationship, or the relationship between height and height measured differently, where we would have a perfect relationship, the relationship between height and weight is strong. Knowing something about someone's weight does tell you something about their height, and knowing something about their height does tell you something about their weight. But it's not a perfect relationship. If I know you're 5'10", I can estimate your weight better than if I didn't know anything about your height, but I still can't estimate it with perfect accuracy. As a result, I would have a correlation coefficient somewhere in the middle, say around 0.7. The value of the correlation coefficient tells you its strength. How much do we know about Y by knowing something about X? How tightly related are these two things? How strongly do they appear together? But the correlation coefficient can also tell us another really important piece of information, that is, the direction of the relationship. So a correlation coefficient doesn't just tell us when things appear together, it also tells us how things appear together. A correlation coefficient tells you as X goes up what happens to Y. In the case of height and weight, as X goes up, Y goes up pretty strongly. But what if I was measuring things differently? What if, for example, I was measuring the relationship between socioeconomic status, how much money you have, and cardiac disease, whether or not you're likely to have a heart attack? So we might expect a negative correlation in this case. As socioeconomic status increases, what happens to the probability of a heart attack? It goes down. So we look both at correlations to determine the strength and the direction of the relationship. So I might have height and weight, which is a positive relationship. As height goes up, weight goes up. But I also might have relationships that are negative, but also might be very strong. So that as socioeconomic status increases, the probability of a heart attack decreases. Let me show you what this looks like visually. Here I have a variety of different scatter plots that might help us understand the relationships between variables. What these scatter plots mean, let's begin with this one here, D. What these scatter plots represent are an individual's score. So each one of these dots is an individual score on two different variables, on variable X and variable Y. And it doesn't really matter what these variables are. What we see here is that this person scored about a 12 on variable X and about an 8 on variable Y. When we look at the overall pattern of these responses, what we see is something that approximates a line with a positive slope that goes up and to the right. What this means is that the relationship between X and Y, on average, is that as X goes up, as we move towards the right end of the graph, Y also tends to go up. We move towards the top end of the graph. If we have a scatter plot that looks like this, we have a positive, relatively strong relationship because these points hug a line. That tells you whether the relationship is strong or not. And go in this direction, have a positive slope, which indicates that the relationship is positive because as X goes up, Y goes up. What if I had a weaker relationship? Let's look at E here. In this case, as X goes up, Y also tends to go up. The line of best fit here still runs in this positive sloped direction. However, the distance from that line of best fit for all of these points is actually much larger. If I were to draw the line here, the average distance from the line of these points would be rather large, especially compared to this. What this indicates is that the relationship between X and Y is not as strong in this scatter plot as it is here. That is, knowing something about X here tells me something about Y, tells me Y is likely to be higher, but doesn't tell me nearly as much about Y as it does in this figure. Here, X is a better predictor of Y than here. What about in this relationship? We have a weaker correlation still, and you can tell that because this R value is closer to 0, but you also see this negative sign in front of the correlation coefficient. This means that this correlation is negative, such that as X goes up, what happens to Y? It tends to go down, not up. The line of best fit here also has a lot of distance between that line and these individual points. What that means is that we have a relatively weak, because it's not a very clear line, negative correlation because that line would have a negative slope moving down and to the right instead of up and to the right. This means that as x goes up, y goes down, and knowing something about x tells me a little bit about y, that it's likely to be lower at a higher value of x than it is at a lower value of x. We can see the more extreme examples of correlations in these scatter plots. A correlation of 0 will appear as a circle. Why? Because remember, that indicates that there's no linear relationship between the variables. As x goes up, what happens to y? I have no idea. It's equally probable that y would be low or high at any value of x. So that means that there's no relationship between these variables, and I know nothing about, say, intelligence based on somebody's height. A and B here show us perfect positive and negative correlations. So this would what would happen if you measured the same thing two different ways. So we see that here, as x goes up, y goes up perfectly. A 30 on x is a 30 on y, a 40 on x is a 40 on y, and we know that if we measure x, we're actually measuring y too. The same thing here, but that relationship is negative. So here a 40 on x is the same as a 20 on y, a 50 on x is the same as a 10 on y. So we have the same relationship, it's perfectly strong, they're exactly the same, but in one case it's a positive relationship where x goes up, y goes up, and the other case it's a negative relationship. I hope you understand these correlation coefficients conceptually, because what I'll ask you to do later is to read a correlation coefficient in an article and be able to explain what that means. So let me give you an example of that. I thought I'd show you a section of the results from a paper that we published a couple of years ago in Psychology of Religion and Spirituality. What we are interested in here is looking at the relationships between general religiosity and prejudice towards a variety of different religious outgroups. What we found in this study can be summarized in a correlation table. You've probably seen some of these in your articles that you've been reading for the skill assignments. So you see a correlation table has different variables listed down this column here. So here we have religiosity, spirituality, attitudes towards Muslims, attitudes towards atheists, and attitudes towards gay men, relative to their majority groups. Here, across these columns, we have the same variables listed. So what this ends up being is a cross table that lets you see the correlation coefficients between any given set of variables. So this R value here is the correlation between religiosity and spirituality. R equals 0.66. Now, based on what we talked about previously, what should immediately jump to mind is that this is a positive correlation. So that means as x goes up, y goes up. So as religiosity goes up, spirituality goes up. That makes sense. If we saw that this was a negative correlation, so that religiosity went up and spirituality went down, that would be counterintuitive, and we want to make sure that we measured things in the right way. So we would expect that as religiosity goes up, spirituality goes up. Now, this also is a moderately strong correlation. What this means is that I know quite a bit about someone's spirituality if I know something about their religiosity. The line for the scatter plot for this would be very tight, to be close to a line, not scattered all over the place like some of the figures that we saw earlier. But what about these variables? So this is the correlation between religiosity and attitudes towards Muslims, attitudes towards atheists, and attitudes towards gay men. We see that each one of these correlations is negative. So what that means is that as religiosity goes up, attitudes towards Muslims go down, attitudes towards atheists go down, and attitudes towards gay men also go down. We see the biggest relationship, the strongest relationship, remember, would be the correlation coefficient that is closest to 1. Which one of these is that? The 0.37. The strongest relationship between religiosity and prejudice in this study was between religiosity and attitudes towards atheists. R equals negative 0.37. That's a negative relationship, so as religiosity increases, attitudes towards atheists decrease, and it's moderately strong at 0.37, so that means I know something about your attitudes towards atheists based on how religious you say you are. We can look at any number of these variables. We would expect, for example, that attitudes towards atheists and gay men might be correlated with each other. So if I look at that, number 4 is attitudes towards atheists, and number 5 is attitudes towards gay men. If I look at the correlation between 4 and 5, I see that I have what kind here? Take a moment and think about it. Is this a positive or a negative relationship? This positive relationship indicates that as X goes up, attitudes towards atheists, Y also goes up, attitudes towards gay men. So the more positive attitudes I have towards atheists, the more positive attitudes I have towards gay men, and the more negative attitudes I have towards atheists, the more negative my attitudes are towards gay men. This is also a moderately positive, or a moderately strong correlation, so we would see a line between these two, and knowing something about your attitudes towards atheists would tell me something about your attitudes towards gay men. What I want you to do in the skill assignment is to look for studies that interest you, look through their results section, find correlation coefficients, and interpret them. Talk about what the scatter plot might look like. I'll provide some details in the skill discussion prompt.